Hello students, how are you all? I hope that you all are good. As we know, the series of motion in a plane is going on and we have successfully finished the 11 lectures, right? So in a previous lecture that we have discussed about Lamis theorem, cosine law and the sine law of vectors. Okay, and what is Lamis theorem? So according to Lamis theorem, if any three forces are acting on a particle to keep it in equilibrium, then each and every force is proportional to the sine of the angle between other two forces. F1 by sine alpha is equals to F2 by sine beta is equals to F3 by sine gamma. So and based on this concept, we have solved some example problems, right? So in today's lecture, that we are going to discuss about position vector, displacement vector, velocity vector, and acceleration in the form of vector, and some examples based on these concepts. Okay, right. Shall we start the session? Okay. So my name is Rakesh Karnanti. Welcome to our beautiful physics channel, Rakesh Sir Physics. Okay, right. So what is the chapter going on? The chapter is what? Motion in a plane. Motion in a plane. Okay, so what is the class number? This is a class number 12. Okay, right. What is a today's concept? And the today's concept is what, ma? So position vector. Okay, right. Have a look. Already we have discussed about a position vector, how to write the position of a particle in two-dimensional coordinate system. Already we have discussed. Okay, so have a look. In two-dimensional coordinate system, as we know, two-dimensional coordinate system consisting of x-axis as well as y-axis. So this is origin O, where the two axes are meet perpendicularly each other. That point is called origin, and the I cap is the unit vector along x-axis and the j cap is the unit vector along y-axis. Okay, so in this plane there is a point P, and the coordinates of this point P are x comma y. Okay, so that means this point is at a x distance from x-axis. Okay, and a y distance from y-axis. From the origin, the position vector of the point P is given by r bar. Okay, so r bar is the position vector of this point P from origin O. So position vector can be denoted by small r bar. Okay, now how can we write the position vector? As we know that the position vector r bar is equals to x into I cap plus y into j cap, x I cap plus y j cap. So this equation gives the position vector of a given vector. Okay, so if you wanted to find the magnitude of r bar vector, so the magnitude of r bar vector is equals to under root of x square plus y square. Okay, so magnitude of a given vector is equals to coefficient of I cap square plus coefficient of j cap square. Okay, so if you wanted to find the unit vector, so what is the formula for unit vector? R cap is equals to r bar by magnitude of r bar. Okay, so vector r bar by magnitude of vector r bar. So that is equals to, what is the r bar vector in two-dimensional coordinate system? The position vector of a particle in two-dimensional coordinate system, x I cap plus y j cap divided by what is its magnitude under root of x square plus y square. So this equation gives what, ma? So the unit vector of a given position vector. Okay, so this is a unit vector, this is the magnitude of position vector, and this is what? Position vector r bar in two-dimensional coordinate system. Is it clear? Any doubt? Right. So in case of a three-dimensional coordinate system, have a look. So this is a three-dimensional coordinate system. This is x-axis, y-axis, z-axis. Okay, I cap is the unit vector along x-axis, j cap is the unit vector along y-axis, and k cap is the unit vector along z-axis, and this is origin O. Okay, so in this three-dimensional coordinate system is nothing but what, ma? It is a space. It is also a space. So in a space there is a particle P, and the coordinates of this particle P are x comma y comma z. X comma y comma z are the coordinates of this point P in a three-dimensional coordinate system, right? So now I want to find the position vector. So r bar gives the position vector of this point P. Now point P is at a distance x from x-axis, y from y-axis, and z from z-axis. Now the position vector r bar of this point P in three-dimensional coordinate system is given by r bar is equals to xi cap plus yj cap plus zk cap. Okay, so if you wanted to find its magnitude, so magnitude of r bar is equals to under root of x square plus y square plus z square. So this is what ma. So magnitude of the position vector in three-dimensional coordinate system. And if you wanted to find a unit vector, r cap is equals to vector r bar by magnitude of r, vector r bar by magnitude of r. So this equation gives what ma? The unit vector of a given vector in three-dimensional coordinate system. Are you getting any doubts? Okay, let me solve some example problem. So example, have a look. Find out position vector of a point, position vector of a point P, that is equals to minus 2 comma 3 comma 6, and its unit vector and its unit vector. Okay, that we have to find the position vector of this point P. So what is the point P? They are given minus 2, 3 and 6. This is what point P, and x comma y comma z coordinates are given. Okay, solution, have a look. So what is the given point P is equals to minus 2, 3, 6. So minus 2, 3 comma 6 are what ma? So the x coordinate, y coordinate and z coordinate. So minus 2 is nothing but what? X, y, z. Okay. Now if you want to write the equation for position vector in three-dimensional coordinate system. So position vector r bar is equals to xi cap plus yj cap plus z k cap. This is a position vector of given point P in a space. Okay, we are having the values of x comma y comma z. Just substitute here. So r bar is equals to what is the value of x? Minus 2 I cap. What is the value of y? 3 j cap plus what is the value of z? 6 k cap. Okay, what they are asking? Position vector they are asking. So this is the position vector of given point in a three dimension. Now what they are asking? Its unit vector. They are asking to find its a unit vector. So what is the formula for unit vector ma? So r cap is equals to r bar by magnitude of r. R bar by magnitude of r. We have the r bar vector and we have to find its magnitude. Okay. So what is the magnitude of r bar vector? That is equals to under root of coefficient of I cap square, that is minus 2 square, plus coefficient of j cap square, that is 3 square, plus coefficient of k square, that is 6 square. Okay. So minus 2 whole square is nothing but 4. 3 3s are 9 plus 6 6 are 36. Okay. So 36 plus 4, how much? 40. 40 plus 9, 49. Root over 49. So root over 49 we got. Root over 49 means 7. So magnitude of vector r bar is equals to how much? 7 units. Just substitute here. So then the unit vector r cap is equals to r bar. What is r bar? Minus 2 I cap plus 3 j cap plus 6 k cap divided by magnitude of r is equals to 7. So this is what? This is a unit vector of given r bar vector in three-dimensional coordinate system. Is it clear? Any doubt? Likewise, you have to do the problems when they are asking the position vector and its unit vector. Okay. So this is about a what? Position vector. So if you wanted to find the direction of given position vector, if you wanted to find the direction, let us consider in two-dimensional coordinate system, this r bar vector is at an angle theta from x-axis. From x-axis, this r bar vector is at an angle theta. Now what they are asking? They are asking to find the direction of r bar. Direction of position vector is equals to how much? So the direction of the any vector is given by the trigonometrical function. What is that? Tan. So tan theta is equals to what ma? Opposite side by adjacent side. So from this figure, what is opposite side? The side which is opposite to an angle theta. Have a look. This is y. Then this is also becomes y. So opposite side y divided by adjacent side x. So tan theta is equals to y by x gives the direction of the position vector. Okay, small concept. Right. So pause the video and write the notes. All these things that we are discussed in our previous sessions only. Okay. So I'm just recollecting all these things, ma. Just pause the video and write the notes. 3, 2, 1, go. Right. So let us discuss about a displacement vector. What is that? Displacement. Displacement vector. So it is denoted by what ma? S bar. Okay, right, have a look. To find the displacement vector, I'm taking a two-dimensional coordinate system. This is x-axis, y-axis. I cap is the unit vector along x direction and the j cap is the unit vector along y direction. Okay, so as we know that this is origin O. In this two-dimensional coordinate system, there is a point A. There is a point A, and the coordinates of this point A are x1 comma y1. X1 and y1 are the coordinates of point A. Okay, so now the position vector of this point A from the origin is r1 bar. So r1 bar is the position vector of this point A from the origin. Okay, right. So in this two-dimensional coordinate system, there is a one more point. There is a one more point. Let us say that point is B. That is a point B. So the coordinates of this point B are, let us say, x2 comma y2. X2 comma y2 are the coordinates of that point B. Are you getting? Right. So now the position vector of this point B from the origin, let us say R2 bar. R2 bar is the what? The position vector of this point B from the origin. Okay. So now I wanted to find the displacement vector. I wanted to find the displacement vector is equals to what? So this is my question. In general, what is the meaning of displacement? The shortest distance between the 2 points is called what? Displacement. The shortest distance between the 2 points is called what? Displacement. Now I wanted to find the displacement between A and B. Displacement between A and B. And taking the vector from point A to point B. Point A to point B. So I wanted to find the displacement in between these 2 points from point A to point B. From point A to point B. So this displacement vector, let us say S bar. S bar be the displacement vector. Okay, so have a look. So this is a r1 bar vector. This is a s bar vector. R1 bar, s bar. These two vectors are in order. Are in order. Therefore, we can write r1 bar plus s bar. R1 bar plus s bar is equals to. Have a look. With respect to these two vectors, r2 bar vector is in opposite direction. Then the resultant of these two vectors is given by r2 bar. Already we have discussed, okay. So what we have to find? We have to find the displacement vector. So from this we can write S bar is equals to R2 bar minus R1 bar. R2 bar minus R1 bar is the displacement vector. Are you getting any doubt? As we know, what is the position vector of this point A? So the position vector of this point A is what, ma? So what are the coordinates? A is equals to x1 comma y1 and B is equals to x2 comma y2. Then the position vector of r1 bar, first vector, is given by x1 I cap plus y1 j cap, and the position vector of point B, that is what? R2, that is equals to x2 I cap plus y2 j cap. Okay, so let us say this is equation number 1, 2, 3. Okay, substitute 2 and 3 in 1. Substitute just r1 r2 here. So you will get s bar is equals to, what is r2 bar? x2 I cap plus y2 j cap minus of, what is r1 bar? x1 I cap plus y1 j cap. So x2 I cap plus y2 j cap plus into minus, minus x1 I cap minus into plus minus y1 j cap. Is it clear? Just take I common. Here I cap is there, here I cap is there. Just take I cap common. You will get x2 minus x1 plus, if you take j cap common, if you take j cap common, then you will get y2 minus y1 into j cap. So this equation gives the displacement vector of a 2 points in two-dimensional coordinate system. This is a displacement vector of 2 points in two-dimensional coordinate system. If you wanted to find its magnitude, so magnitude of s bar is equals to under root of coefficient of I cap square, that is x2 minus x1 whole square, plus coefficient of j square, y2 minus y1 whole square. And if you wanted to find the unit vector of your displacement vector, so it is given by s cap is equals to s bar by magnitude of s. So just substitute this and this here, you will get the displacement vector. Is it clear? Any doubts? Right. Easy one, Amma. Okay. So already we have discussed. Okay. Right. So next we have to find the displacement vector in three-dimensional coordinate system. In 3D we have to find it. Okay. So right. So in a three-dimensional coordinate system, so this is x-axis, y-axis, z-axis. Okay. So from the origin there is a point A. So the coordinates of point A are x1 comma y1 comma z1. Okay. So now the position vector of this point A, let us say r1 bar. Okay. So another point B is there. Okay. So the coordinates of point B are x2 comma y2 comma z2. Okay. And this is what r2 bar. Okay, now if you want to find the displacement vector, the shortest distance between the 2 points is called what? Ma? Displacement. Now I wanted to find the displacement from point A to point B. That is what? S bar. Already we have discussed the same thing. Okay, same thing we have discussed. So displacement vector from the diagram is given by R2 bar minus R1 bar. R2 bar minus R1 bar. In three-dimensional coordinate system, what is the position vector of point A? That is R1. So R1 is equals to what is the point A? Ma? So point A is equals to x1, y1, z1. So point B is equals to x2, y2, z2. So R1 bar is equals to x1 I cap plus y1 j cap plus z1 k cap. So R2 bar is equals to x2 I cap plus y2 j cap plus z2 k cap. Are you getting? If you want to find the displacement vector, simply displacement vector is equals to R2 bar minus R1 bar. So that is equals to R2 bar x2 I cap plus y2 j cap plus z2 k cap minus R1 bar x1 I cap plus y1 j cap plus z1 k cap. Okay, so that is equals to x2 I cap. Amma, simple mathematics. Okay, so please follow me. So minus into plus, minus x1 I cap, plus into minus, minus y1 j cap, minus into plus, minus z1 k cap. So just take I cap, j cap, k cap common. So if you take I cap common, you will get x2 minus x1 I cap. Have a look. Here x2 I cap is there, minus x1 I cap is there. If you take I cap common, you will get x2 minus x1 plus y2 minus y1 j cap. If you take j cap common, you will get y2 minus y1. If you take k cap common, you will get z2 minus z1 k cap. So what is this? This is a displacement vector in three-dimensional coordinate system. Displacement vector in three-dimensional coordinate system. And if you want to find its magnitude, if you want to find its magnitude, s bar is equals to under root of x2 minus x1 whole square plus y2 minus y1 whole square plus z2 minus z1 whole square. So this is a magnitude of displacement vector in three-dimensional coordinate system. Are you getting any doubt? And if you wanted to find out yes, yeah, unit vectors are all these things. What all these things are? Just things are they are eating our brain. So don't get attention. Easy things, man. Okay, now. So all these things are easy things, and if you got the question from this concept, then you don't skip it because it is an easy concept. Okay, I will explain the problem based on this concept. Okay, don't worry. So what is unit vector? So s cap is equals to s bar by magnitude of s. So just substitute this vector and the magnitude of s bar vector here, you will get unit vector. Right? Any problem? Just we are find the displacement vector in two-dimensional coordinate system. The same thing we did for three-dimensional coordinate system, but the extra thing here we got z1 and z2. Have a look. x1 I cap plus y1 j cap. x1 I cap plus y1 j cap. Just extra thing z1 z2 we got. Just it becomes z2 minus z1 k cap. We are added one extra thing, small extra thing. Any difficulties there? Any problem? Right. So just pause the video and write the notes. 3, 2, 1, go. Let's we solve one example problem on this concept. Okay, don't get attention. 3, 2, 1, go. Example problem. The coordinates of 2 points are given. Let us say point A is equals to 3 comma 4 comma 5 and the point B is equals to minus 2 comma minus 6 comma 7. Okay, so 2 points are given, right? So find out the displacement vector. Find the displacement vector and its unit vector and find its unit vector. Okay, right. So just pause the video and try the solution. So same concept. You have to use same concept, but at the place of x1, y1, z1, we have 3, 4, 5. At the place of x2, y2, z2, we have minus 2, minus 6, 7. Okay, just pause the video and try the solution. 3, 2, 1, go. Have a look. The solution. So what is the point here they are given? 3 comma 4 comma 5. What is the point B? Minus 2, minus 6, 7. So what is this? X1, Y1, Z1, X2, Y2, Z2. Okay. So I'm just going to write a displacement vector directly. So what is S bar? So displacement S bar is equals to X2 minus X1 I cap plus Y2 minus Y1 J cap plus Z2 minus Z1 K cap. Okay. So X2, what is the value of X2? Minus 2. Minus what is the value of X1? 3 I cap plus Y2, what is the value of Y2? Minus 6 minus what is Y1? 4 J cap plus what is Z2? 7 minus what is Z1? 5 K cap. Okay. Any problem is there not? So displacement vector is equals to what? X2 minus X1 I cap plus Y2 minus Y1 J cap plus Z2 minus Z1 K cap. Okay. So X2 minus X1, Y2 minus Y1, Z2 minus Z1 I cap, J cap, K cap. So minus 2 minus 3 minus 5 I cap plus minus 6 minus 4 minus 10 J cap 7 minus 5 7 minus 5 2 K cap. Okay. Minus 2 minus 3 minus 5 minus 6 minus 4 minus 10 7 minus 5 2. So minus 5 I cap minus into plus minus 10 J cap plus 2 K cap. This is what ma? So this is a displacement vector. So we got a displacement vector. Now what we have to find? Unit vector. S cap is equals to S bar by magnitude of S. So we have to find magnitude of displacement vector. So that is equals to under root of coefficient of I cap square minus 5 whole square plus coefficient of J cap square minus 10 square plus coefficient of K cap square 2 square. So that is equals to under root of 5 square 25 plus 10 square 100 plus 2 square 4. So 100 plus 25 125 125 plus 4 129 root over 129. So the unit vector S cap is equals to what is S bar? Minus 5 I cap minus 10 J cap plus 2 K cap divided by root over 129. Okay. So this is what the unit vector of a displacement vector. Displacement vector from given 2 points in three-dimensional coordinate system. So what is the formula? X2 minus X1 I cap plus Y2 minus Y1 J cap plus Z2 minus Z1 K cap. So if it is in two-dimensional coordinate system, so there is no Z term. So just X2 minus X1 I cap plus Y2 minus Y1 J cap. That's it. Okay, in two dimension. If it is in three dimension, just you have to add Z2 minus Z1 K cap. Is it clear? Any doubts? Right. So easy problems now. Okay. So easy concept also. Right. So pause the video and write the notes. Pause the video and write the notes. 3, 2, 1, go. Right. So let us discuss about a velocity vector. Okay. Have a look. Velocity vector. So velocity vector can be denoted by V bar. So I wanted to find the velocity vector in two-dimensional coordinate system. Okay, two-dimensional coordinate system. First, I'm going to find the average velocity. Okay, so average velocity. So average velocity is nothing but what ma? Change in displacement divided by change in time, or change in position divided by change in time. So change in position of the vector delta r bar divided by delta t. In two-dimensional coordinate system, what is the position of a point? So r bar is equals to, already we got, what is that? X I cap plus y j cap. Just substitute here. Just substitute here. So average velocity is equals to delta. What is r bar? X I cap plus y j cap divided by delta t. So that is equals to, have a look, I'm just expanding this term. It becomes delta x I cap divided by delta t plus delta y j cap divided by delta t. So what is this? Average velocity. Okay. So what is delta x by delta t? So delta x by delta t is nothing but delta x by delta t. So the rate of change of the position of a particle in x-axis gives velocity of the object in x direction, Vx bar. So what is delta y by delta t gives? The rate of change in the position of the particle in y direction, given by Vy, is given by Vy. Just substitute here. So then average velocity is equals to Vx I cap plus Vy j cap. Vx I cap plus Vy j cap. Are you getting any doubt? Right. Now if I want to find out, this is the average velocity, ma. Okay, so what is this? Average. Now if I want to find the instantaneous velocity, I want to find instantaneous velocity. Instantaneous velocity. So how to find the instantaneous velocity? So when we got the instantaneous velocity, when already we have discussed, okay. So delta t tends to 0. The time tends to very small. Instantaneous, the velocity of the particle at a particular instant of time, at a smaller interval of time, is called a instantaneous velocity. So have a look. So I'm just considering this equation as a 1 and I'm just writing directly. Okay, now I'm just writing directly. Ma. Already we have discussed all these things. Okay, right. So from equation 1, so the change in time is very small. The particular instant of time, equation 1 becomes limit delta t tends to 0, limit delta t tends to 0, V average, V average. So whenever the time is very small, then this term becomes what, ma? Instantaneous velocity. It becomes instantaneous velocity. So now we can write equation 1 as V instantaneous is equals to instantaneous velocity is equals to, just apply limit delta t tends to 0 on either side. It becomes delta x by delta t I cap plus limit delta t tends to 0 delta y by delta t j cap. So whenever the delta t tends to 0 in a slope concept, I told you that the denominator is tends to 0 is very much closer to 0, then delta becomes d. Then delta becomes what, ma? D. So v instantaneous is equals to, now this term becomes what, ma? Dx by dt I cap plus dy by dt j cap. That's it. What is dx by dt? So dx by dt is nothing but vx. Dy by dt is nothing but vy. Okay, just substitute here. So v instantaneous velocity is equals to vx I cap plus vy j cap. Okay, now if you want to find its magnitude, if you wanted to find its magnitude, so magnitude, so how to find the magnitude? Just apply mod. So v instantaneous is equals to under root of coefficient of I cap square vx square plus coefficient of j cap square vy square. Okay, now if you wanted to find the unit vector, so v cap is equals to v bar by magnitude of v, that is equals to vx I cap plus vy j cap divided by under root of vx square plus vy square. Okay, now if you want to find its direction, if you wanted to find its direction, so direction, so how to find the direction? So in a two-dimensional coordinate system, this is what? X-axis, y-axis. So this is a net resultant velocity vector. So this v bar vector, let us consider it is making an angle theta with the x-axis, and its x component is vx and its y component is vy. Are you getting? Already we have discussed it now. Okay, I'm just writing directly more. Okay, so from this, if you wanted to find the direction, then tan theta is equals to opposite side by adjacent side. So tan theta is equals to what, ma? So what is opposite side? Vy. What is adjacent side? Vx. So tan theta is equals to what? Vy by Vx. So this gives the direction of the resultant vector in two-dimensional coordinate system. So this is a vector form of velocity. So this is what? The magnitude of the velocity. This is direction of the velocity in two-dimensional coordinate system. In two-dimensional coordinate system. Is it clear? Any doubts? Right. Now if you wanted to find out velocity vector in 3 dimension, velocity vector in 3 dimension. So just in a 3-dimensional coordinate system, the velocity vector is equals to vx I cap plus vy j cap plus vz k cap. So these are the velocity vector in 3-dimensional coordinate system. Okay, and if you wanted to find its magnitude, so v bar is equals to under root of coefficient of I cap square plus coefficient of j cap square plus coefficient of z cap square. So this is the velocity vector in 3-dimensional coordinate system and its magnitude. Okay, right. So just pause the video and write the notes. Just pause the video and write the notes. Any doubts? Any difficulties there? Simple na? Okay. Three. Right. So let us see one application based on this velocity vector whenever the particle performing the uniform circular motion. Okay. So based on this application, there is a one previous year JEE main question is there. Okay. Have a look. What is that application? So application number one. Have a look. A particle, a particle performing, a particle performing a uniform circular motion, a uniform circular motion with a constant speed, with constant speed v, a particle performing a uniform circular motion with constant speed v. Have a look. So this is a origin O. So from this center, so this is a radius vector r. Now the particle performing the uniform circular motion with constant velocity v. Okay, then the magnitude of, then the magnitude of change in velocity, then the magnitude of change in velocity, that is delta v. So the magnitude of change in velocity of the particle, of the particle when it describes, when it describes an angle, when it describes an angle theta, theta at the center, theta at the center. Okay, so the formula is, so have a look, when it is performs a uniform circular motion with constant velocity v, then the change in magnitude of the velocity delta v when the particle makes an angle theta at the center, that is delta v is equals to 2v sin theta by 2, 2v sin theta by 2. So based on this formula, based on this formula, we have direct JEE mains question. So what is that? So the change in magnitude of the velocity of the particle when it describes an angle theta at its center. What is that? Delta v is equals to 2v sin theta by 2. Okay. So and the formula for average acceleration. What is this? Average acceleration is equals to 2v square sin theta by 2. 2v square sin theta by 2 divided by r into theta. 2v square sin. So average acceleration is equals to 2v square sin theta by 2 divided by r theta. Just remember these two formulas are important. We have a direct question on this formula. Maybe they are asked at this time based on average velocity. We don't know now. So please remember these two formulas. Okay, right. So what is the previous year question they are asked? Have a look. JEE mains 2019. Okay, right. So this is the JEE mains previous year question based on this formula, direct formula. Have a look what they are given. A particle is moving in a circular path with constant speed 10 meter per second. So what is the speed of the particle they are given? 10 meter per second, and this speed must be constant. Have a look here. So the speed of the particle is constant. Speed or velocity, whatever it is constant. So what is the change in magnitude of the velocity of the particle? So delta v, change in magnitude of the velocity of the particle is equals to how much? When it moves through an angle 3 degrees around the center of a circle. So what is the formula? So direct formula, change in magnitude delta v is equals to 2v sin theta by 2. 2v sin theta by 2. So that is equals to 2 into what is v? What is the velocity of the particle? 10 meter per second into sin theta. What is theta they are given? 60 divided by 2. 2 ones are 2 30s are 30 degrees. So 2 into 10 into what is the value of sin 30? The value of sin 30 is 1 by 2. 2 get cancelled, that is equals to 10. So delta v is equals to 10 meter per second. That's it. So direct formula. Just remember this. If they are asked to find the average acceleration, what is the formula for average acceleration? 2v square sin theta by 2 divided by r theta. Divided by r theta. What is r? R is nothing but what? No? So radius. R is nothing but what? Radius of the circle when the particle performing uniform circular motion. R is what? Radius. So just substitute here. So 2 into what is the velocity of the particle? 10 into v square is there, ma. So 10 into 10 into sine 60 divided by 2, sine 60 divided by 2. Let us say radius is r into what is theta? 60 degrees. So that is equals to 2 ones are 2 30s are. So 2 into 10 tens are 100. The value of sine 30 is 1 by 2 divided by r into 60 degrees. So 2 to get cancel out. So we got 100 divided by 60 degrees into r. So this is the average acceleration of the particle. Just write down these two formulas and this problem. Okay, right. So pause the video and write the notes. Pause the video and write the notes. 3, 2, 1, go. Right. So let us we discuss about our last concept of our session, that is acceleration in the form of vector. Okay. So acceleration vector, acceleration in the form of vector. Okay. Right. Have a look. In general, what is the meaning of average acceleration? So average acceleration is nothing but what, ma? So the change in velocity divided by change in time. Okay, so just now we have discussed what is velocity vector in 2 dimension. I'm talking about 2 dimensional coordinate system. So in 2D, so what is velocity vector? So vx I cap plus vy j cap. Okay, so let us say this is 1, this is equation number 2. Substitute 2 in 1, substitute equation 2 in equation number 1. Then we get our average acceleration, that is equals to delta, what is v bar? So vx I cap plus vy j cap divided by delta t. Okay, I'm just expanding this term. So have a look. Delta vx by delta t into I cap, delta vy divided by delta t into j cap. So what is delta vx by delta t? So delta vx by delta t. So the rate of velocity of the particle along x direction gives acceleration of the particle along x direction, a bar. Okay. So delta vy by delta t, the rate of change of the velocity of the particle along y direction gives ay. Gives what, ma? Ay. Just substitute here. Then we got average acceleration. Average acceleration is equals to ax I cap plus ay j cap. So what is this, ma? This is average acceleration of the particle. So now if you wanted to find out instantaneous acceleration, so change in time tends to 0, then this equation, I'm taking the equation number, let us consider this is the equation number 3. I'm just taking the equation number 3. So limit delta t tends to 0, then average acceleration, becomes instantaneous acceleration. Average acceleration becomes what, ma? Instantaneous acceleration. Just substitute here. So instantaneous acceleration is equals to limit delta t tends to 0, delta vx by delta t I cap plus limit delta t tends to 0, delta vy divided by delta t into j cap. So whenever the delta t tends to 0, the denominator is very much closer to 0, then delta becomes d. D means what, ma? Differentiation. Okay. So here, so acceleration, instantaneous acceleration is equals to this term becomes dvx by dt I cap plus dvy by dt j cap. What is dvx by dt? So dvx by dt is nothing but what, ma? So the rate of change of velocity of the particle along x direction gives acceleration of the particle along x direction. So dvy by dt, the rate of change of velocity of the particle along y direction gives ay. Okay, so just substitute here. So the instantaneous acceleration is equals to ax I cap plus ay j cap. So this is what, ma? Form of acceleration in 2-dimensional coordinate system. Okay, so if you wanted to find its magnitude, so that is equals to under root of ax square plus under root of ay square. Okay, if you wanted to find its unit vector, a cap is equals to a bar by magnitude of a, and if you wanted to find its direction, So its direction can be given by tan theta. So tan theta is equals to what, ma? So have a look, ax I cap plus ay j cap. So y component divided by x component. So this is what direction of the acceleration. Okay. Now if you wanted to find the acceleration in three-dimensional coordinate system in 3D, if you wanted to find in three-dimensional coordinate system and its acceleration a bar is equals to, so you will get ax I cap plus ay j cap plus az k cap, ax I cap plus ay j cap plus az k cap. Any doubts? So simple concepts. Okay. So please write the notes properly. So with this, all the concepts of today's session will be completed, and let's see, do the example problems. Are you ready? Right. Pause the video and write the notes. 3, 2, 1, go. Right. So I'll just bring the two example problems based on our concepts. Okay. I will. So what is the first example? The velocity and acceleration of a particle at a time t is equals to 0. So they are given velocity and acceleration of the particle at a time t is equals to 0. That means initial velocity and initial acceleration are given. So initial velocity of the particle is given. U is equals to how much, ma? 2 I cap plus 3 j cap meter per second. Okay, sir. What is the acceleration of the object given? So acceleration is equals to 4 I cap plus 2 j cap. So meter per second square. So acceleration also given initially at a time t is equals to 0. This is when, ma? Time t is equals to 0. What they are asking? Find velocity and the displacement. So velocity is equals to how much and the displacement is equals to how much. Okay. So at a time t is equals to 2 seconds. At time t is equals to 2 seconds, we have to find its final velocity as well as its displacement. Is it clear? Any doubts? Okay. So I'm going to find the final velocity. We know the time and the initial velocity of the object. We have to find final velocity. So by using first equation of motion, what is that? V is equals to u plus at. V is equals to what, ma? U plus at. Okay, so what is V? We have to find, we don't know. What is U? 2 I cap plus 3 j cap plus what is acceleration? 4 I cap plus 2 j cap. What is time? 2 seconds. Okay, so that is equals to 2 I cap plus 3 j cap plus 2 for the 8 I cap plus 2 to the 4 j cap. So that is equals to 2 plus 8, 10 I cap plus 4 plus 3, 7 j cap. So this is what, ma? So the final velocity of the object at 2 seconds. Final velocity of the objects at 2 seconds. Right. Next, what we have to find? We have to find displacement. So the displacement equation S bar is equals to what, ma? Ut plus half at square. So these are the vectors. So S bar is equals to what is U? U is nothing but 2 I cap plus 3 j cap into time 2 seconds plus half into what is acceleration 4 I cap plus 2 j cap into what is time square 2 square. So 2 get cancelled out. So this is equals to 2 to the 4 I cap plus 2 3 the 6 j cap plus here 2 is there 2 4 the 8 I cap plus 2 to the 4 j cap. So what is this one? This is a displacement vector. So the displacement vector S bar is equals to 4 plus 8 12 I cap plus 4 plus 6 10 j cap. So what is this? This is the displacement vector of the object after 2 seconds. So this is the final velocity of the object after 2 seconds. So these are our answers. Any difficulty is there? Right. Let's see solve that example problem. What they are asking, have a look. The coordinates of a body. They are given the coordinates of a body moving in a plane in a two-dimensional plane means two-dimensional. The object is moving in a two-dimensional plane at any instant of time t. At a particular instant of time, the coordinates are what? X is equals to this coordinate and y is equals to this coordinate. So the velocity of the body is what? They are asking to find the velocity of the body. They are given x coordinate, y coordinate. So we have to find the velocity along x coordinate and y coordinate. After that, we have to write the equation for velocity vector in two-dimensional coordinate system. That's it. That is the answer. Just pause the video and try the solution. Are you getting? 3, 2, 1, go. Have a look. solution. I'm going to solve the solution. They are given now x and y coordinates. So x is equals to alpha t square and y is equals to beta t square. What they are asking, the velocity of the object is equals to how much. So we know the x coordinate. So if we wanted to find the velocity vector along x direction, then the formula vx is equals to dx divided by dt. Already we are discussing now. Okay. So dx, d by dt of what is x? Alpha t square. So alpha is constant and the t square, differentiation of t square is 2t. So this is what v x bar, velocity vector along x direction. Next, if you want to find a vy, so vy is equals to dy by dt. So vy bar is equals to d by dt of what is y? D t square. So beta is constant, it comes outside. D by dt of t square, differentiation of t square is 2t. So this is what? V y. Now if we want to find the velocity vector, so velocity vector v bar is equals to vx I cap plus vy j cap. Okay, these are the vectors. What is vx? 2t into alpha plus what is vy? 2t into beta. So if you take a 2 common, 2t common, then you will get alpha plus beta. So this is the velocity of the object in that plane. Any problem is there? Simple problems, ma. Okay, right. Let us discuss two more examples, and those are level 2 problems. Okay, right. So pause the video and write the solutions. 3, 2, 1, go. Right. So this is an example number 3. So have a look. Big question. Right. So one thing you should remember, when you are doing the problems in physics subject, you must have a patience to read the complete question. Okay now. Once if you understood the question what they are given, then you can solve the answer easily. Okay now. So you have a patience to read the question. Okay. Right. Have a look what they are given. A figure shows the rod of length L resting on a wall and the floor. Okay now. This rod is resting on the floor and the wall like this. Okay, so its lower end capital A is pulled towards left with a constant velocity v. So with constant velocity v, this end of the rod is pulled. So what happened? The rod will be moves in a downward direction like this. It moves like this. Okay, so find the velocity of the other end B. So whenever this rod is moving in downward direction, what we have to find? We have to find the velocity of point B. When the rod makes an angle theta with the horizontal, when the rod is makes an angle theta with the horizontal, that means before it completely reaches the ground, so when it is making an angle theta with the floor, we have to find the velocity of point B. Okay, can you try the solution? Right, very good. Just pause the video and try the solution. 3, 2, 1, go. Have a look. I'm going to solve the solution. So one thing is clear that the length of the rod is L. So throughout the motion, the length of the rod L is what, ma? Constant. It is clear. So let us consider this distance is x. Okay, na? The floor distance is x, and the distance traveled by this rod along a wall, let us say y. This is x and this is y. So have a look. We have the x coordinate and y coordinate. Then we can write the velocity equation. So what is that? Velocity of the particle at point A is equals to dx by dt. So velocity of the particle A is equals to how much, ma? Dx by dt. So have a look. Velocity of the particle at B. Have a look. Whenever this rod is moving towards the floor, whenever this rod is moving in a downward direction towards the floor, this y component is decreases. So this is a rod of length L. Okay, so when it is moving towards the ground, initially it height, let us say 10 meters. Let us say 10 meters. Y is equals to 10 meters. So whenever it is moving towards the ground, then what happens? The y coordinate will be decreases. That means, so 9 meters, 8 meters, 7 meters, 6 meters, 5, 4, 3, 2, 1, 0. Okay, before it reaches to the ground or before it reaches to the floor, we have to find its velocity. when the rod makes an angle theta with the vertical. So one thing is clear that so the y component will be decreases. Then the velocity of the particle at a point B is equals to minus dy by dt. What is negative sign shows? Negative sign shows y is decreases. Y is decreases. The displacement of the object along y direction will be decreased. If we observe the diagram carefully, have a look. One right angle triangle is formed. So L, Y, X, this is 90 degrees. Right angle triangle is formed. Then from this we can write hypotenuse square is equals to side 1 square plus side 2 square. I'm just differentiating this equation. Differentiating above equation with time. I'm just differentiating above equation with respect to time. So then it becomes, have a look, what is L? L is a constant term. So throughout the motion of the rod, L is constant. Differentiation of constant. Differentiation of d by dt of L is equals to 0 because it is constant. So 0 is equals to, so d by dt of x square plus d by dt of y square. So it becomes differentiation of x square 2x dx divided by dt plus differentiation of y square 2y dy by dt is equals to 0. From this we can write 2x. What is dx by dt? So dx by dt is nothing but velocity of an object A plus 2y into what is dy by dt? So dy by dt is nothing but, here minus is there. If minus comes to this side, it becomes minus vb. Minus vb is equals to 0. So I'm just writing this equation as 2x into va is equals to minus into plus minus. If minus term went to that side, it becomes plus 2 by vb. Have a look, 2 get cancelled out. So x into va is equals to y into vb. What they are asking? Velocity of the point B. Velocity of the point B is equals to how much? Okay, have a look. Find the velocity of the other end B. Velocity of VB is equals to how much? So then we can write VB is equals to x by y into VA. What is the velocity of the object at a point A? VA is equals to how much? Velocity of the particle at a point A is equals to V. So VA is nothing but V x by y into V. So this is our answer, but our answer is in the form of cos theta, tan theta, cot theta in trigonometric functions. Have a look. We got a x by y, x divided by y. Here angle theta is there. So this is L, this is theta, this is 90 degrees, this is y, this is x. Okay. So we have x by y. We have what ma? X by y. What is x? X is nothing but adjacent side. What is y? Y is nothing but opposite side. So in trigonometrical functions, which function gives adjacent side by opposite side? Adjacent side by opposite side. What is tan theta? Tan theta is nothing but opposite side by adjacent side. Are you getting ma? Opposite side by adjacent side is nothing but tan theta. But we have adjacent side divided by opposite side. So the adjacent side by opposite side is given by the reciprocal of tan theta. 1 by tan theta is nothing but what ma? Cot theta is what? Cot theta. Are you getting any doubts? If you want to find these things, so just listen my lecture. So basic mathematics used in physics, trigonometrics by Rakesh sir. You will get these things. Okay, right. So we got VB is equals to what ma? What is x by y? X by y is nothing but cot theta. So V into cot theta. So where is V into cot theta? Option A is our answer. Any difficulties there? Simple problem, na? Right. So pause the video and write the solution. Pause the video and write the solution. 3, 2, 1, go. Right. So this is a last question of today's session. Okay. So are you happy? I know you are very happy because session is ending now. Right. So have a look. What is the question they are given? In the arrangement shown in a figure, the ends of an inextensible string move downwards with uniform speed u. They are arranged one system like this, okay, and they are just pulled these ends of the strings with uniform velocity u. Now what happens? This mass m is moving in upward direction. We have to find the velocity of this block m. That is the given question. Okay, right. Pause the video and try the solution. 3, 2, 1, go. Right, I'm going to solve the solution. Have a look. Initially, the system is like this. Okay, so they are applied a uniform velocity u and they are pulled these strings in downward direction, and this block is moves in a upward direction. So at any particular instant of time t, so the block is makes the displacement x with this side, and this side is also makes the displacement x. Okay, at any particular instant of time the displacement of the object is in this direction, is, let us say, x, and along vertical direction the displacement of the object, let us say, y be the displacement of the object along vertical direction. Okay, the total length from this end of the pulley to this end of the pulley, let us say small l. Have a look, they are given two equal angles theta and theta. That means whatever the vertical line is there, it divides this length l into l by 2 and l by 2, half of the length. That means this is a midpoint. Okay, so have a look, if you observe carefully, here one right angle triangle is formed. So this is an angle theta, this is x. Okay, so this is what, y, and this is l by 2. From this diagram we can write a hypotenuse square x square is equals to side 1 square plus l by 2 whole square. Are you getting? Hypotenuse square is equals to side 1 square plus side square. So I'm just differentiating this equation with respect to time. Differentiate above equation with respect to time. Okay, then d by dt of x square is equals to d by dt of y square plus d by dt of l square by 2, sorry, l by 2 whole square. Have a look, half of this length l by 2 is a constant. L by 2 is what, ma? It's a constant term. Length does not changes when the block moving in upward direction. So the differentiation of constant is becomes 0. Differentiation of constant is how much, ma? 0. So d by dt of x square, so 2x dx by dt, 2x dx by dt. So that is equals to differentiation of y square, 2 by dy by dt, 2 by dy by dt. So here 2 get cancelled out. So we got x into dx by dt, that is equals to y into dy by dt. Okay, right. Sir, what is dx by dt and what is dy by dt, sir? Have a look. Whenever we are applied the uniform velocity in downward direction, what is the change in the displacement of the object? U is equals to x is the change in displacement of the object in both sides. Then velocity can be written as dx by dt. So this u can be written as change in displacement of x divided by dt. But have a look, this velocity is in downward direction, and when we are pulling this string in a downward direction, this x will be decreases. Then we can write u is equals to minus dx by dt. So here minus sign shows decrement in x, are you getting? Or u in downward direction, either it shows the direction of the u because it is in downward direction, or decrement in x. Okay, are you getting? Any doubts? Okay, so have a look, this is y, and I'm taking the final velocity of the object along vertical direction. I'm taking as a v be the velocity of the object in vertically upward direction, final velocity. So what is the displacement in vertical upward direction? Y be the displacement and v be the velocity. Then v can be defined as v is equals to dy by dt. V is equals to what, ma? Dy by dt. Are you getting? Just substitute here. X is equals to what is dx by dt? Dx by dt is nothing but what, ma? Minus u. That is equals to y into what is dy by dt? So dy by dt is nothing but v. So v is the final velocity of the object when it is moving in upward direction, and we have to find v. So v is equals to, we can write minus x by y into u. Right. From this, here we got x by y. What is x? X is nothing but hypotenuse. divided by, because it is opposite to 90 degrees. So whatever the side is opposite to 90 degrees, that is hypotenuse. What is y? Y is nothing but adjacent side, the side which is along an angle theta. This is what ma? Adjacent side. So we got hypotenuse divided by adjacent side. Hypotenuse divided by adjacent. So cos theta, in general, cos theta is nothing but what ma? Adjacent side by hypotenuse. So here we have hypotenuse by adjacent side. Hypotenuse by adjacent side. It gives what ma? 1 by cos theta. So x by y. X by y is nothing but what ma? So from this we can write v is equals to minus, what is x by y? X by is nothing but 1 by cos theta into u. So we got finally u by cos theta. Minus is nothing but it shows the direction ma. Okay, it shows only direction. So remaining term is what? U by cos theta. So u by cos theta is option C is our answer. So we can also do this problem in another method. Okay, in a simple method we can do this problem. So have a look. Method 2. Okay, let's have a look. These two velocities are acting on this mass m in downward direction. So with respect to these two velocities, this block m is moving in upward direction. This block m is moving in upward direction with velocity v. Have a look. This velocity v is making an angle theta with the x and theta with the this x. So along theta side you will get velocity component is what ma? V cos theta. Along theta side, this side is also you will get v cos theta. Are you getting? So this is a final velocity. Along theta side, you will get v cos theta. Along theta side, you will get v cos theta. So v cos theta in upward direction. These two u's are in downward direction. So then we can write. So this is in downward direction now. So I'm taking minus u. Okay. So this v cos theta in upward direction plus v cos theta. This v cos theta is also in upward direction plus v cos theta. This u is in downward direction, minus u is equals to 0, minus u minus 2u plus v cos theta 2v cos theta is equals to 0. If 2v cos theta went to that side, it becomes 2v cos theta is equals to 2u. 2 get cancelled out. Then u is equals to v cos theta. So what we need? We need final velocity. Then v is equals to u by cos theta. V is equals to u by cos theta. Are you getting? Any doubts? Okay. So this is a shortcut method and the easy method. So this is a concept oriented method. Okay. So which is easy, you should practice that method. Okay. Right. So pause the video and write the notes. Pause the video and write the notes. 3, 2, 1, go. Right. So this is the end of the today's lecture. Okay, I hope that you are understood position vector, displacement vector, velocity vector and acceleration vector and some of the examples based on those concepts. And we have discussed one application, important application. We have previous year JEE main question on that concept. So they are asked the velocity of that object when it is performing uniform circular motion. Maybe next time they will ask the acceleration of the object. We have the formula for that acceleration also. Okay, so please practice all these things. Don't waste your time. Every minute is important. Okay, right. So it's time to say signing off. Can I say? Right. So this is Rakesh Karganti signing off. Stay tuned. Jai Hind.